multiplication of two matrices. So here, assume that you have a matrix. You have a matrix which is of order m by n, and another matrix with order n by p. Okay, then multiplication is possible. What does that mean? The number of columns of first matrix is equal to number of rows of second matrix. This is the condition for multiplication. Number of columns in the first matrix and number of rows in the second matrix has to be equal. Only then multiplication of two matrices are possible. So this is the condition. Now, what will be the resultant matrix? What will be the order of the resultant matrix? So the order of the resultant, what I meant by resultant is after multiplication, what is the product? That product matrix, okay? The order of the resultant matrix is m by p, okay? It's going to be m by p, number of rows of the first matrix by number of columns of the second matrix. So this is the basic requirement of multiplication. What is the requirement? Number of columns of first matrix is equal to number of rows of second matrix. And after multiplication, what is the result going to be? The order of the resultant matrix is going to be m by p. Okay. Now let me give you an example. Okay. 3 by 2 matrix. See, if A is a 3 by 2 matrix, what should be the order of B? If order of A is 3 by 2, what should be the order of B for multiplication to be possible? It should be 2 by, here I can do anything. Okay, it can be 2 by 1 or 2 by 2, anything is possible. Okay, so I'm writing 2 by 2. If I write 2 by 2, what will be the matrix, the resultant matrix? Resultant matrix is going to be 3 by 2. This 3 and this 2. That makes the order of the matrix. Now, how to do the multiplication? So A is going to be, let it be 5, 2, 5, 2, then maybe 3, 1 and 6, 3. This is 3 rows and 2 columns. This is A, and let matrix B be 3, 2, 4, 1. Okay, so this is matrix B. Now I need to multiply, right? So when I multiply, what I need to do is this element. Okay, first row, consider the first row and consider the first column. Okay, just at the moment, just consider first row and first column. What I'll do is 5 is multiplied with 3. Okay, 5 and 3. Then I add 2 into 4. This becomes the first element of the resultant matrix. What did I do? I just multiplied 5 into 3 plus 2 into 4. Okay. Now, what is going to be the second element? Second element is this 5, 2, same first row need to be multiplied with this column. Okay. So at that time, it is going to be 5 into 2 plus 2 into 1. So this is the second, first row, second column element. Now, similar step I have to do with the second row. What is second row? Second row, 3, 1. So 3 is multiplied with this 3 into 3 plus 1 is multiplied with 4. Similarly, for the second row's second column, what I'll do? 3 into 2 plus 1 into 1. So here, so 3, second row, 3 is multiplied with 3 plus 1 is multiplied with 4. Then again that I need to multiply this 3, 1 to 2, 1. So 3 into 2 plus 1 into 1. Now what will be third row? Third row.
For the third row, you take 6 into 2.
Why 2? First
6 into
column.
3, sorry. 6 into
Yes,
3.
6 into 3.
Plus 3 into 4.
3 into 4. Yes, that becomes the first element of the third row. And what is the second element?
The second element is 6 into 2 plus 3 into 1.
2 plus 3 into 1. That's correct. Now just solve it and this is your answer. Okay. So 5 3s are 15 plus 8. This is going to be 10 plus 2, 9 plus 4, 6 plus 1. Then 12 plus 3. So this is what I'm getting. This results in 15 plus 8 is 23, 12, 9 plus 4, 13, 7, 18 plus 12 is 30, 15. So this is the final answer. And what did I tell you about the final answer? M by N, if the matrices are M by N and N by P, the final order of the matrix, the resultant matrix will have the order M by P. So it should have 3 rows and 2 columns. And look at the final answer. It has 3 rows and 2 columns. So this is how you perform multiplication. We need to find the product of 2 matrices. A is equal to 3, 4, 5, 0. P is equal to 1, 2, 3, 4. Find AB. Okay. So first you need to look at the order of the matrices. This is 2 by 2 matrix. This is also a 2 by 2 matrix. Since it's a 2 by 2 matrix, it is going to be, it's like number of columns of the first matrix and number of rows of the second matrix are same. So multiplication is possible. So now you can go ahead and do the multiplication.
Like multiply 3 into 1.
1 row and 1 column.
Okay.
That's how you have
3
to
into 1
perform.
and 4 into 3. Then.
Yes. So it's going to be 3 into 1 and 4 plus 4 into 3. That's how we are connecting. Okay. Now, what is the second element? That also you tell me. What is the first element of the first row?
First row, first element is 1.
No. First.
For A part, right?
Yes, yes.
So for A part, first row, first element is 3.
3. Okay, so I need to start with 3.
Yeah.
3 needs to be multiplied with the 3. Multiplied with what? 2.
Okay.
Second column. Okay.
And then 4 will be multiplied by 4.
Yes, this is how you should do. If there are another 2 more columns, then for each column, I have to keep on doing this. Same process will be continued.
5 into 1.
Yes.
Plus 0 into 3.
0 into 3, that's right.
5 into 2.
5 into 2.
Plus 0 into 4.
Plus 0 into 4, that's all. So this is what you're getting. Now the result is 3 plus 3 plus 12. Here it is 6 plus 16. Here it is 5. This side it is 10. So the resultant is going to be 15, 22, 5, 10. Okay. Next question. Next question.
Yes, ma'am.
Yeah. A is equal to negative 2, 3, 4, 1. B is equal to 1, 2, 3, 5. Find first part AB, second part BA, and you need to find out whether BA and AB are equal. Okay.
I have a doubt.
Tell me.
And will A, B, and B be the same answer?
No, no, that's what I'm trying to prove here. A, B, and B are not same.
And
Okay.
if you do 3 into 4, it's equal to 4 into 3, right?
Yes, the order will be different, right? For the row is multiplied with, see, in the
Okay.
case of AB, A's row is multiplied with B's column, first column, or each column. Okay, so that matters. Okay, so AB.
Mine, -2 into 1 plus minus 2 into 3.
No.
I mean 4 into 3. 4 into 3.
1 minute.
Sorry.
This,
Yeah, 3
and
into
always
3.
you
3
circle
into
it.
3.
Okay, then you
3
will not
into
be
3, sorry.
confused. Yes, yeah.
3 into 3.
It's going to be 3 into 3. Yes, and second element.
4 into 1.
Is it second row you're talking about, or second?
Yeah, ma'am.
Second row. Okay, 4 into 1.
Plus 1 into 3.
1 into 3. Okay, 4 into 1 plus 1 into 3. Can you tell me the second column? Here. This is
Okay, sorry. -2 into 2
minus 2 into 2. That's right.
plus 3 into 2.
3 into
5.
3 into 5. Yes. And next one. Next this element.
4 into 2
4 into 2
plus 1 into 5.
1 into 5. That's correct. So multiplication, you might get confused. So always write for one row you circle it, and then column also you circle it. Then you will, then it will be there in your mind. Okay, you need to multiply the row with the column. So just do this kind of circling and then you start. Now let this be -2 plus 9. Here it is -4 plus 15. This is 4 plus 3, 8 plus 5. This is answer is 7, 11, 7, 13. Okay. BA is, let me write B and A once again. B is 1, 2, 3, 5. A is -2, 3, 4, 1. Can you tell me the first row?
Okay, 1 into 9.
I'll circle it. Okay, I'll circle it so that I don't want anyone to go wrong. Yes.
1 into -2 plus 2 into 4.
That's right.
1 into 3 plus 2 into 1.
That's correct. Yes. Now
Ma'am, the second row.
Second row. Yes.
So in the second row, it is 3 into -2 plus 5 into 4.
That's right. And
in the second element, it is 3 into 3 plus 5 into 1.
plus 5 into 1. Yes. This is going to be -2 plus 8, 3 plus 2. This is -6. -6 plus 20, 9 plus 5. This is equal to 6, 5, 14, 14. This is the final answer. So check whether AB and BA are equal or not. What is the answer for AB? AB is 7, 11, 7, 13. 7, 11, 7, 13 is AB. Whereas BA is 6, 5, 14, 14. So this is not commutative. AB into multiplication is not commutative for matrices. This you need to remember. You can write it as a note. Multiplication is not commutative for matrices. Question is, A is equal to negative 3, 3 to negative 2. B is 4, 6, 4, 6. Find AB. Okay. Question is find AB.
First, minus 3 into minus 4. No, sorry,
Mhm.
minus 3 into 4, my bad. Plus
Okay.
3 into 4.
Plus 3 into 4. Okay.
Right? For the second part, it will be 3 into 4.
Uh,
No,
and
second. First, it will be 3 into 3 into 4, right?
you have already done it, right?
No.
Negative 3. Negative 3 into 4 plus 3 into 4 is already done.
Yeah.
Now,
Second,
now
minus 2 and 2.
no.
No.
Now the first row itself, see, it is like first row you have to do with each and every row. If it has, not every row, every column. If it has got 3 columns, you have to do this with 3 columns.
Yeah.
First row with first row of the first matrix.
Yeah.
With the first column of the second matrix, second column of the second matrix, third column of the, how much ever are there, that you have to continue. Got
Okay.
it? So,
Yeah.
tell me.
It will become 2, right? First. What do you have to write?
No, are you talking about the element here or
Yeah.
here?
Element down.
Down? Okay.
Yeah.
Tell
It will
me
become
then.
2 into 4 plus 2 into 4, right?
2, yes, 2 into 4 plus, what is
2
the
into
second
4.
element?
2 into 4.
Negative 2 into 4.
Oh, yeah, my God. Yeah. Okay.
Negative 2 into 4. Okay.
Okay.
Now,
Now
what
the
about?
element on the right, top right.
Yes.
Right. It will become 3 into 6 plus 3.
Negative, you cannot skip.
Okay.
Negative 3 into 6
Yeah.
plus
3 into 6.
3 into 6.
And
Yes.
then the bottom one will be minus 2. No, bottom one will be first 2 into 6 plus minus 2 into 6.
Yes, 2 into 6 plus minus 2 into 6.
Okay, got
This
it.
is correct. Yes, this is correct. Okay. Now just need to add up and get the answer. So you're getting a zero matrix here. Even if the matrices are non-zero, sometimes when you multiply two matrices, you will get the result. The resultant matrix will be zero. It need not be the what you are multiplying. Those matrices need not be zero. Even without those matrices being zero, you will get the result zero. That is possible. Okay. So the product of two non-zero matrices can be a zero matrix. Okay. So the product of two non-zero matrices can be a zero matrix. Yeah. Question is A is equal to 4, negative 4, negative 3, 3. B is equal to 6, 5, 3, 0. And C is equal to 2, 3, negative 1, negative 2. Show that AB is equal to AC. Okay, this is what you have to show. B and C are not equal matrices. Okay, B and C are not equal matrices. Still, they are asking us to show that AB is equal to AC. Let's see whether it is possible. Let's do AB. AB first. So let me write A. And then B is 6530.
Yes, ma'am. So first 4 into 6. 4 into 6 plus minus 4 into 3.
Then
Then
you have to continue with first row of the first matrix and second column of the second matrix.
okay, 4 into 5 and minus 4 into 0.
Yes, minus 4 into 0. Can you tell me the second row?
Ma'am?
Second row.
Minus 3 into 6 plus 3 into 3.
Plus 3 into 3. And second column. Second row, second column.
Minus 3 into 5 plus 3 into 0.
Plus 3 into 0. Yeah. Now let's do AC. Two, 3. Minus 1, minus 2.
4 into 2 plus minus 4 into minus 1. 4 into 3 plus minus 4 into minus 2.
Minus 4 into
Minus 2.
minus 2. Yes.
Then
4
minus
into
3 into
minus 3 into
2
2 plus,
plus 3 into minus 1.
that's right.
Minus 3 into 3 plus 3 into minus 2.
Yes. Yeah. So 12, 20 minus 9 minus 15. This is AB is equal to AC. The metrics B and C are not equal. Still, AB was equal to AC. AB and AC are equal even though B and C were not equal metrics. Okay, this point you need to remember.
B and C are not equal. How are they not equal?
B and C, they are not equal. No, look at the B and C, look at B and look at C and tell me, are they equal?
Okay, so saying by the values. Okay, okay, ma'am. Yes, ma'am.
They're not equal matrices, right? So when, see, what I wanted to prove is B and C are not equal. Still, AB is equal to AC. Okay, that is not possible with normal numbers, normal integer numbers or normal rational numbers. If you go and multiply, this will never happen. But with matrices, this will happen. Okay, now what is an identity matrix? Or there is a definition, right? And what is the definition saying? It should be a square matrix. Secondly, it's a diagonal matrix. Thirdly, leading diagonal should be 1. 3 points are there for an identity matrix. First point, square matrix. Second point, diagonal matrix. Third point, leading diagonal should be 1. So if I write 1, 0, 0, 1, this is an identity matrix of order 2, or you can say 2 by 2. Okay. Now the question is, if I write, there is one important point which you need to remember. When I multiply A with A is a matrix. When I multiply a matrix A with identity matrix, okay. See, I have told you when A is multiplied with B and B is multiplied with A, that's not equal, right? AB is not equal to BA. But in this case, when identity matrix, when you multiply with A, or the other way, you are multiplying I into A, both will result in A only. Here, identity matrix, you are multiplying with A, or A is multiplied with identity matrix, it will result in A itself. So this is an important point that you need to remember. So when I say 5i, okay, 5i means it is 5 into, but they will mention in what order. Is it a 2 by 2 matrix or is it a 3 by 3 matrix? That they will tell you. Like, you know, I is an identity matrix of order 2 by 2, or I is an identity matrix of order 3 by 3. Like that, they will tell you. So here, if it is an I is an identity matrix of order 2 by 2, then it is more like, you know, 1 0 0 1, which will become 5 0 0 5. Okay, so this is how you should be doing this. Now, one question, let's do example 11. A is equal to 2 negative 1 negative 1 3. 2 negative 1 negative 1 3. Evaluate a square minus 3a plus 2i, where I is a unit matrix of order 2. So if they are saying of order 2, you should understand that they are talking about 2 by 2, because I is an identity matrix. It has to be a square matrix. In a square matrix, number of rows and number of columns are equal. So when they are talking about identity matrix, they will just say identity matrix or unit matrix of order 2. They won't say 2 by 2. They'll just say 2. So you should understand that they are talking about 2 by 2 because it's a square matrix. Okay, so here first part is calculating a square. How do you calculate a square? What is a square? A square is a into a. So 2 negative 1 negative 1 3 into 2 negative 1 negative 1 3. This is called a square, a into a. Got it? Now multiply.
Ma'am, so it's going to be 2 into 2 plus minus 1 into minus 1.
Yes.
Then on the right side, 2 into minus 1 plus minus 1 into 3.
Yes. Okay.
Then down, minus 1 into 2. Then plus 3 into 2, 3 into minus 1.
Yes.
And then on the right side, minus 1 into minus 1 plus 3 into 3.
Yes, that's right. Now let's solve it. 2 into 2 is 4 plus 1 minus 2 minus 3 minus 2 minus 3 plus 1 plus 9. So I'm getting 5 minus 5 minus 5, 10. Okay, now we need to calculate 3a and 2i. So what is 3a? 3a is 3 times a. What is a? A is 2 negative 1 minus 1 3. So you just need to, it's like scalar multiplication. 3 is the scalar. You are multiplying a scalar with the matrix. So each and every element of the matrix, you need to multiply with 3 in this case. So 3 into 2 is 6. 3 into negative 1 is negative 3. 3 into minus 1 is again negative 3. 3 into 3 is 9. Next is 2i. So that we can do together. So what I am going to do is a square minus 3a plus 2i is equal to, what is my a square? 5 minus 5 minus 5, 10 plus, not plus, it was minus 3a. So 6 negative 3 negative 3 9. 6 negative 3 negative 3 9 plus 2i. 2i means 2 0 0 2. That is the meaning of 2 into I. Okay. So this is what you need to do. Now let's calculate. What I'll do is plus 5 plus 2. 5 plus 2 is 7. 7 minus 6 is 7 minus 6 is 1. Now minus 5. Here it's minus 5 plus 3. That minus 5 plus 3 is minus 2. Then here minus 5 plus 3 is minus 2. 10 plus minus 9 is 10 minus 9 is 1. Right? 10 minus 9 is 1. 1 plus 2 is 3. This is what I am getting. Multiplication is possible or not, you should first check. Huh? So if I am giving you a matrix 3, 5, 2, 8, and I am giving you 1, 3, 5, can we perform this multiplication or not? You need to check that. For that, first you write down the order of the matrix. So first matrix order is 2 by 2. Second matrix order is 3 by 1. So do you think this number of columns of the first matrix and number of rows of the second matrix should be same? In this case, they are not same. So when they are not same, multiplication is not possible. So first thing to check is that. So here you can say that multiplication is not possible. For this question, you can write like that. Next question is example 14. 3, negative 8, 9, 4, x, y is another matrix, is equal to negative 2, 8. Find x and y. First you multiply. Okay, how do you multiply this? This is my first row and there is only one column. So multiply that. So 3x minus 8y, right? 3x minus 8y. For the second row, I am getting 9x minus, no, plus 4y. This is what I am getting as the product of 3, negative 8, 9, 4 and xy. This is equal to negative 2, 8. So can I form two simultaneous equations from this? This is equal matrix, right? Left side is equal to right hand side. So can I write 3x minus 8y equal to negative 2 and 9x plus 4y equal to 8. So I got two equations, two simultaneous equations. Can I solve it now? Simultaneous equation is, you can follow substitution method, but sometimes in this case, substitution gives
Subtract the equations.
Elimination would be best here. So we can go ahead with elimination. For elimination, one of the coefficient has to be made equal. So I am going to make y coefficients same. For that, I need to just multiply second equation with 2. Because when I multiply second equation with 2, I can make the y coordinate, coefficients of y the same. So 18x plus 8y equal to 16. Okay, this is my equation 3. Now what I'm going to do is 1 plus 3. Equation 1 plus 3 implies 3 plus 18 is 21x is equal to 1 and 3 is what I am adding. Okay, so 18 plus 3 gives me 21x and minus 8y plus 8y becomes 0. 16 minus 2 is 14. So what is x? X is 2 by 3. Now we need to calculate y. Maybe we can substitute. Put x is equal to 2 by 3 in equation. Which one? Equation 1 probably. So you get 3 into 2 by 3 minus 8y equal to negative 2. So here 3 and 3 will get cancelled out. 2 plus 2 equal to 8y implies y equal to 4 by 8, which is 4 by 8, which is y equal to 1 by 2. So x is equal to 2 by 3 and y equal to 1 by Question is, if B and C are two matrices such that B is equal to 1, 3, negative 2, 0, and C is equal to 17, 7, negative 4, negative 8, find M so that BM equal to C. Okay, so they want us to calculate, they want us to find out M. M is a matrix. They have not given the order of M. You have to find out the order of M and then provide. So what you will do here is C value, you know the value of B. Good. So let's write that first. B is 1, 3, negative 2, 0. What matrix is this? This is a 2 by 2 matrix. And what is the order of C? C is 17, 7, negative 4, negative 8. This is again a 2 by 2 matrix. So from this, what you need to understand is the result of, how is it going to be the result? This multiplication is possible only if the number of columns of the first matrix and number of rows of the second matrix are equal. So I have to make what is the number of columns of the first matrix, that is going to be number of rows of the second matrix. So I found out the value 2 here. Okay, number of rows in matrix M is going to be 2. From where did I got it? Because I know if matrix multiplication has to be possible, it is possible only if number of columns of first matrix is equal to number of rows of second matrix. So that's how I am getting 2. The row is number of rows of the second matrix as 2. I also know that the resultant matrix will be of the order. What will be the order of the resultant matrix? Number of rows of the first matrix by number of columns of the second matrix. The resultant matrix is going to be number of rows of the first matrix by number of columns of the second matrix. So again, here it is a 2 by 2 matrix. So you can understand that this is also going to be a 2 by 2 matrix. Which one? M is also going to be a 2 by 2 matrix. Now, we don't know the elements of M at all. You don't know the elements of M. So what will you do? Just put A, B, C, D, 4 unknown values, because this matrix will have 4 elements because it's a 2 by 2 matrix. So just put A, B, C, D, and then you are going to perform the multiplication and then solve it. Let's try it. It is going to be first row needs to be multiplied with first column, and then first row needs to be multiplied with second column. Okay, so usual multiplication approach is what we are going to do. It is going to be 1 into A plus 3 into C, then 1 into B plus 3 into D. Next row, negative 2 into A plus 0. 0 into C, I don't need to write that because 0 into C is 0 only. Then negative 2 into B plus 0 into D. This is equal to 17, 7, negative 4, negative 8. You write it as it is. This is going to be A plus 3C, B plus 3D, negative 2A, negative 2B. This is equal to 17, 7, negative 4, negative 8. Now, negative, you can say A plus 3C equal to 17. It's an equal matrix, right? So you know each corresponding elements are equal. So A plus 3C is equal to 17. B plus 3D is equal to 7. Negative 2A equal to negative 4 implies A equal to 2. Now, negative 2B is equal to negative 8. implies B is equal to 4. Next is, I need to figure out now A value and B value are known. Now put it in the other two equation. Maybe I can write this as equation 1, this as equation 2. Put A equal to 2 in equation 1. Then I will get 2 plus 3C equal to 17 implies C is equal to 17 minus 2 is 15. So 15 by 3 is 5. Now put B equal to 4 in equation 2. It will be B is 4 plus 3D equal to 7. 3D equal to 3 implies D equal to 1. So therefore, M is going to be, how will M look like? A, B, C, D is what I told you, right? So 2, 4, C is 5, 1. This is my M matrix. 2, 4, 5, 1. In the place of A, B, C, D, you put the corresponding values.